Okay. Match each expression with an equivalent expression. That is the deal.
Is this the quiz? This is the quiz, right?
Straight up quiz.
Nice.
Let me go back to it just to make sure I have the quiz correctly done. Do we have an individual quiz this week?
We have an exam.
Okay. Because I remember one time
But the exam is due. Oh, sorry, go ahead.
I just remember 1 week that she had us do an individual quiz, even though we had a regular exam. I thought that was screwy, but you know. Just checking real quick. 2 things. What the heck?
So we're trying to see which one like equals it's true, right? Essentially, we're like verifying it. We're just trying to find out
it's matching. It's matching. I was just trying to make sure that I got the right matching stuff down.
So what if we each just take? Well, I don't know how we do that. I guess.
I knew it. Okay, yeah, I knew there's going to be some errors. Okay, let me correct a few. Oops. I think it just didn't seem right. But it was not supposed to be. Oh, I should know.
Well, this changes the equations completely.
Yep, I felt like there was some error. That's not. Oops. Okay. There we go. So she didn't put these letters in there. That's why I put them in black. They're not originally in. Oh, she did put the letters in there. Psych. I thought she didn't. So these are the correct letters that she wants us to put. Well, what I can see so far right off the bat is that this one is C.
Yeah.
I think that's a fair statement.
Yeah, so I just looked at it, which quiz I did, and I accidentally did week 12.
That's
Yeah, which
probably
makes sense.
why.
Well, at least you're done with week 12 now.
Well, I want to email her back and be like, can I try it again? Or just see if I can do, I don't know how she's going to do it. Because I slept for hours on that quiz.
You're like, what the heck?
I know, I was already like a little pissed off that I had to do homework in the Seattle airport, and I was like, This has nothing to do with what we did in the homework.
It's the best airport, man.
But yeah, you should have come and said hi. I was there for like 4 hours.
Oh boy.
Could have helped me out with my quiz.
Did you at least get some Starbucks in the cultural essence of Seattle?
Yeah.
Nice.
But Starbucks is everywhere. I should have got. Their food court is pretty sick. How it looks
true.
over the runway.
Mm-hmm.
Anyways, we lost the quiz. You're screen sharing. You're screen sharing. You're not screen sharing anymore.
I was trying to figure out how I was gonna make it so I could cross out the C, so we didn't use it again. There we go.
Oh.
Okay, so I just highlighted the one that we already did. No, we don't.
Okay.
Use it again. And then you know what I think would be a smart way to do this?
What?
Calculate all these numbers out and then write them to the side.
Like on a calculator?
Mm-hmm.
Okay, let me go get my calculator.
I think that'd be a smart move.
All right. Do you want me to do the bottom one?
Fun. You could do the right if you wanted.
The right?
Yes.
I'm pretty sure that cosine 12 is going to equal the 1 plus cosine 6 over 2, because I'm pretty sure you just multiply it out. No.
That's what I was thinking too.
Well,
There's 1 plus though.
yeah, that's what I was thinking. Are we, huh?
The answer, okay, so did you want me to do the right side?
Yeah, do the right side.
Okay, so E is 0.99726. -2 sine. All right, -2 sine 5 sine 1 is
This one.
negative 0.00304. All right, you ready for cosine 12?
Cosine 12. Yeah.
I think B is actually, it goes with the third line down.
That's
cosine
what I was thinking.
12.
I think it goes
Cosine 12 is
cosine
0.97815. Two cosine 5 sine 1. Let's try that one.
I don't know why it's taking me forever, but it is.
Yeah, so I just went through it. So B is equal to cosine squared 6 minus sine squared 6.
So A, 2 cosine 5 sine 1, is .03477.
0.03.
Which is the same thing as, yeah.
Oh,
A is in between B and C.
that's convenient.
So we're trying to find out A, D, and E, right? Left? Oh, no, we just found A. So we're trying to find D and E.
Cosine 6 minus cosine 4. Or is it times?
It's definitely a minus.
And then I got E as being equal to the 1 plus cosine 6 over 2, which would only leave D left. So E and D
I
are
found,
just
oh yeah,
exactly across from each other.
yes, that's what I found too.
Yeah, me too.
Yeah.
I'm not BSing. That's actually weird I got.
Yeah.
So you guys already on vacation?
I'm staying here for vacay,
Oh, that's right. You live there.
I'm
but
not
my
yet.
folks are over.
Yeah, my wife and I have to drive down to Arizona here tomorrow.
Didn't you just drive from Arizona to Rexburg?
We drove from New Mexico to Rexburg a couple
Oh,
weeks
my
ago.
bad. Yeah, that
Driving
was my
down
bad.
to Arizona, and then we're going to go from Arizona back to New Mexico, and then we're flying to DC for Christmas. So
My wife and I, we got in yesterday at like 5 a.m. into Alaska. And we're here for the
nice.
week. Because I'm missing an Alaskan dog.
Who do you have in Alaska that you're up there seeing?
It's my dad.
Nice.
Got
My
his.
wife and I, we worked up in Alaska for a summer. We loved it.
Where is it?
It's fun.
Can you see that caribou on the wall right there? Giant caribou on the wall. Okay. For the proof of the first product to some identities is given to you in the e-text.
I don't know what this question is. So you have the product, some identities, right? Is that one? Or is that the same thing?
Yeah.
Product to sum to product. Is this like the double life, half life, sum product, and product sum? Is that what this is asking? You know what I mean? Anybody?
Not a
Bueller?
clue. That's
Bueller?
Are these the identities that like 1 plus tangent squared or theta equals secant squared theta?
No, I think this is like the half-life identity that we had to do, and then the double life as well. Because I think they all have their opposites. I think that's product to sum, and then there's sum to product, and then there's half-life and double life. But I'm not sure. It may not be half-life, but there's something along those lines. I can't remember what it's called. Let's see here. We can skip this one while I'm trying to find it. I'm going to look in the e-text and see if there's the product sums, and then while I'm doing that, somebody else can do the next problem or something.
Okay. Find all the angles alpha in 2 pi. That satisfy the equation sine 2 theta equals tan theta. Chris, do you know how to do this? We can't hear you if you're talking to us.
How's that?
That's much better.
I don't know why it does that.
I'm just glad that you're not ignoring us. So I don't remember how to do this, to find the angles.
Guess I could do that.
Excuse me.
Goodness.
Oh. Let's see here. Product is
This is becoming very difficult.
Okay, so the book has both product to sum and then sum to product. So I think as long as we can prove that those two are equal, we can get number 3.
So sum to product then?
Yeah, so there's a sum to product one that we can use.
Shoot. By that I meant, if you want to explain it.
Well, I'm reading it right now, actually. Sum to product
Be ready,
identities.
man.
So sum to product is essentially sine A times cosine B equals 1/2 of sine A plus B plus sine A minus B. So it's just kind of showing you that it's an inverse.
Equals what?
And I'll just screen share real quick again. Well, if I can get it up. What the heck is it?
It's hiding.
I love when you can never find your screen. You're clicking through every single one you have until you finally. Then text. So this is the sum to product. If we can see. So it's just showing like right here, if you have the product of sine A times cosine B, you can write it as 1/2 sine A plus B plus sine A minus B. And then you just kind of solve it that way. Maybe this is.
Can you just hold it right there? Thank you. I just took a little screenshot. That way you don't have to hold it on that screen.
You know, I'm probably not going to be doing much else, so. and difference identities. It doesn't stop sharing now.
You what?
Yeah.
So I guess can stop screen sharing now.
Any fun plans for the holidays?
My wife and I are going to New York. That's about it, though. So that should be exciting stuff.
Which holiday is that for?
Christmas.
Oh. Dude, if you were gonna be any closer, my wife and I would come and see you. We're gonna be in Maine.
Oh, nice. Well, drive
Yeah.
on down.
You what?
Said, well, drive on down.
That nice 8-hour drive.
Yeah, it's not too bad.
Yeah, compared to someone who drives to Arizona and New Mexico on the weekly.
It's enjoyable, I guess. Something like that, right?
Once you get out of Utah, it's nicer.
That's true. I hate the drive through Utah. It's so long. Takes forever.
From like Vegas to Nephi, takes forever. No, not Vegas. Cedar City, St. George
That
area,
is
Cedar
true.
City. From there to Nephi, it's a while.
Yeah, it's a long drive.
Yay, we did it. Woo. Okay. Number 3. Let's do this. Find all the angles alpha in 0, 2 pi that satisfy the equation. Mm-hmm.
So is this just, well, because it has to satisfy the equation. So we have to use all 6. No, because it's all find all the angles. I'm assuming in this one we have to use all 6 of the trigonometric identities to find the angles that is showing.
No, because this is not an
And
identity.
then plug that back in and see if they equal each other.
I feel like there's got to be a...
each answer, and then we can find out which ones are equal to.
Between 0 and 2 pi. Let me think about that. Hmm.
Well, here's a 52-second video if you guys want to watch it on how to do it.
Yeah, is it the one that
Or
has
I
like
guess
the
I
white
could
on or the
just watch
whiteboard
it
on the
and then
background?
explain it.
Yeah, go ahead, display it, man.
Well, actually, my internet's not letting me load it, so
Do you want me to do it? Is it the one that says find all angles that satisfy a tangent equation?
yeah. I don't think this is going to help.
Hmm.
Oh, thank you.
That didn't answer my question.
Well, anybody receive any enlightenment on that?
Trying.
I can clearly see that Chris's page has the homework up, but every time I go to click on him, it doesn't show the homework. It just shows a blank page. But I can click on, oh, there it is. Never mind.
Find all the angles in 0, pi, 2 pi that satisfy.
Hmm. Hmm.
Well, should we try and do number 4 first then, since we don't know how to do this one, and then we can come back to it?
Sure. This 4 looks a little bit more promising.
Yeah.
Use an appropriate identity to find the exact value of the expression. Sine of 285 equals, oh, just the sign of subtraction. Identity. I think. Maybe.
I think and maybes are always good, right?
Possibly.
So are you just trying to get the rest of it written out?
Yeah.
Cosine 285 times sine 15.
Wait, oh yeah, sine 15. You're right. Minus cosine 15 on side 285, excuse me.
Yep.
Times sine of 285. Wait. This should be actually. This should be sine. It should be cosine. It should be cosine. SOS. But yes, SOS. There we go. I think that's an appropriate identity. Do you guys think that's an appropriate identity?
Well, we can verify if
Yes.
it's true, right?
I think so.
Because if it works, then we should be able to verify that it works for true. So, yep, that works. So we're good.
So I found that this one equals -1, which is equal to that. So I'm just gonna do this real quick. -1 sine of 285. But I'm writing this out. Maybe one of you could get started on the other one, number 3.
Yeah, I'm looking it up right now.
Excellent, excellent, as Mr. Burns would say.
Did you forget something?
Any Simpsons fans out there?
You what?
Is anybody a fan of the Simpsons out there?
I thought the movie was pretty good. That would be important. Yeah.
Say what?
I'm sorry, just talking to my dad.
Oh,
Just having some good old family time.
It's like I'd be doing right now if I wasn't stuck here doing this. I mean, you guys are great and all, but
I think your true feelings toward us are starting to come out, Chris.
no, actually,
No, I'm just kidding.
I think it'd be fun to like show with you guys next semester if we're on campus. That'd be cool. Just not doing this.
This is gonna be off subject. But, James, were you at Best Buy like 3 days ago?
Yeah.
And I don't. Okay, I
Yeah. Was I?
Yeah, you were.
Was I with somebody else?
Around. Yeah.
Yeah. So that was my wife's brother.
Gotcha. Yeah, I saw. I was like, "Is that him?" I can't tell if it's you or not.
Dang. Wait.
I was in the GoPro
yeah.
section like the entire time.
Oh. Yeah, I if I would have seen you, I would have come up to you. Actually, I probably wouldn't have.
Yeah.
Dang, that was nuts.
Yeah. Wait a minute. That looks like James. I said your name a couple times, but no one like looked up and I was like, yeah, well, I'll just. I don't think it's him.
Dang, you said my name.
Yeah.
Dang, man, that was my bad.
It's all good.
All right, guys. I gotta use the restroom real quick. I'll be right back.
All right. All right.
All right. So I found this out, and what they did is theirs equals 1, but I don't know if ours equals 1. They basically solved for one side and then found out where those lie on the unit circle, and then found everything that would work within that unit circle for that specific part.
But in between 0 and 2 pi, that's once around completely the unit circle.
Oh, well.
That's like the
You
entire
see,
unit circle.
they have 0 and 2 pi, but their equation's different. And so that was the answer. What they did is they solved for this, so they divided the 2 out, and then took the square root of both sides and got to theta. And then they looked at the unit circle and found sine theta, which equals these.
Root 2 over 2.
And so they did positive and negative, and then found the angles for the negative as well. And that gave them all of their unit sets. But is our equation equal to 1?
No, it's equal to tangent of alpha. She made it more complicated. So I was watching videos. I was finding videos and researching and doing the same, but they're all saying that sine of angle what have you equals a certain number, or sine of angle, so not equal to tangent of alpha.
Well, maybe if we do sine 2a tangent of a,
which I did as well,
I want
but
to see
then
if
they're
it says
still
true. How should I
sticky.
answer? I do not know.
On the other side.
Maybe if I do 2a.
I was about to go in. You didn't even know it. I was about to start rapping.
Me and my companion MTC I used to beatbox, and he used to start rapping. It's pretty funny.
I could never do that. I always got stuck after the second line because I can't work that far in advance.
What if we put in 0 into sine 2a and tangent of a, find the number that sine comes out to, and then we could find out all of the angles. Because 0 equals what? X and y or r and theta, which doesn't do anything for us. Maybe it does, but I have no idea.
One more dished effort. You know, I have my brother-in-law here who's going to Stanford. Maybe he may be able to shed some light on this situation.
Going to Stanford or Stanford?
Like Stanford in California.
Oh, not Stanford in Alabama.
No.
And what is he studying?
Physics. Yeah.
Oh, yeah, you could probably do something.
You know, I'll ask him. I'll be right back. I'll ask him real quick.
Oh, you know what? If we just subtract tangent over, then it equals to 0.
Hey, not a bad
How?
idea. That's actually
Then you
a
have
smart idea.
that on one side. And then you could make tangent, and if you take that into its inverse or whatever, so it would be negative sine A over cosine A plus sine over
Would that be
sine
subtract then?
2A. Well, yeah, it's subtracting.
Yeah.
You'd subtract it. That's not the answer, though.
No, of course not.
Okay, I thought you were highlighting that to answer it. And then you could do sine 2A minus sine A over cosine A to try and simplify it down into one formula,
Sure. I had a professor at BYU at home campus that said that. It was pretty funny.
And just simplify it all out.
Me and one of my classmates used to make fun of him for it.
That's funny.
Not during class, of course, but
Yeah, whatever. So if you multiply that by what? Cosine? Oh, well, we could put if we put sine over 2a over 1, added them together. Sine A over cosine.
Oh man, I gotta blow my nose. For real. Sorry.
Come on. Then we could combine those somehow, right? Because if you put it over 1, then that'd be 2a over cosine A. So we gotta combine those somehow to get it into one thing.
Did you guys figure it out?
Well, I'm thinking if you put sine A over 1, then you can put the fractions together. And so you'd have negative sine A plus 2 or plus sine 2A
Plus sine 2a.
Times cosine A. That's times cosine A, though. It'd be times cosine A when you combine the fractions. Yeah, and then all over cosine A. I'm pretty sure that's how they're combined together. And that all equals 0.
Of course.
And then we've got to somehow simplify that to get it out of a fraction.
Would these cosine alphas cancel each other, though?
I'm not
Or
sure.
would that work?
Not sure.
And then a negative sine A plus a sine of 2A would equal... Oh, no, that wouldn't get us nowhere. We're trying to find the angles. Well, just don't beat all.
Well, if you multiply it by cosine, over cosine, then one of the cosines would, then it'd cancel out, wouldn't it?
Yes.
So if you multiply it by cosine over cosine, then you'd just be left with negative sine A plus 2 cosine squared times sine A. Because you'd have to multiply the cosine up, and because you'd have 2 cosine, because when you added it, then if you multiplied it, it'd give you cosine squared. You'd have
Of
to
alpha?
Yeah, so I think you'd have sine A, or negative sine A like you have, plus 2 sine squared alpha times sine A equals 0. And then from there, you could pull a sine A out because you've got 2 sine A's to simplify it down to cosine. So you could factor sine A out.
So just be 2 cosine squared A?
There's another identity that I don't know if it would help us in this problem, but it's the double angle formula, and sine 2a sine 2a is equal to 2 sine u plus cosine u, or cosine a plus sine a. So let me say it again. Sine 2a is equal to 2 sine a cosine a.
Well, we don't have a sine 2a. We have a cosine 2a.
Well, no, I mean in the original problem. So sine 2a is equal to 2 sine a cosine a.
What was that again?
Sine 2a is equal to 2 sine a cosine a.
Open it up a little bit. Times cosine A?
Yeah. And tangent a, isn't that sine over cosine?
Mm-hmm. Possible. Yeah, so get rid of this part up front just to make it less confusing. But then what angles would satisfy this equation then?
I don't know.
Let's try it.
For the denominator on the right side, you just multiply both sides by cosine A.
Uh-huh. So this would be 2 cosine A, I believe.
Yeah, and then you can divide out that sine A.
So we just 1 sine over here?
Yeah.
Equals just that.
Yeah.
But I don't know. Then what does it equal? That's the problem.
Find all the angles in the entire unit circle that satisfy the equation.
Sure.
Sine A times 2 cosine A. Wouldn't it be equal to 0 on that other side?
I thought, but maybe.
This is confusing me to what the unit circle even looks like.
I could ask my brother-in-law real quick.
Yeah, I mean, you could go ahead. I'll just keep opening Google Pages to see if it helps.
Write it down. See if we... Take a little picture here. Be right back.
Okay. Jason, you have any clue what's going on?
Well, I was going off of mine, and when I factored out the negative sine A, it left me with sine A, or sine A parentheses 2 cosine squared A minus 1. And then I took the square root of it. And so then I'm assuming that we can solve that as like this or this or this, and then try and figure out the unit circle from there. But I'm just waiting to see what other options are there.
Yeah, it's like on all of the examples on the internet, at least they all show that there's an exact value that they have. Like either it's 1 or it's 1/2 or 2 square root 2 over 2.
Well, and that's why I think we have to get it to 0, you know?
Mm-hmm.
Because then when it equals 0 and you're down to the simple fraction, like the 1, then you can plug in your
Mhm.
numbers and you can find out where each thing lies. And that's what I was trying to get to. So
Well, when it's 2 cosine A, can't we just take the 2 out? No.
no, because you have the cosine squared A, which I think makes it different. I don't know.
Well, I was looking at the top part,
Oh,
but then you would
yeah, I don't
have
think
0 divided by 2.
yeah.
0 divided by 2 is not a thing.
Well, the problem is you'd have to take the A with it too because it's attached to it. And
Right.
so you'd have to do 0 times, 0 over 2 angle, which would be 0 for your angle. So I don't think that'd work.
Yeah, I agree.
I find? What did I find? Did I find it here, Chesney? Where's my baby? Oh, hi. Hi. I'll bring you baby. Oh, cool fingers. I bring you. Oh, it's so pretty. So nice.
Make it baby.
Did you guys figure it out?
No, I was kind of
I-
banking on your brother-in-law.
Yeah. You banked right because he did it.
Was I
Okay,
close?
that makes not even.
Dang it.
So he said, here's how to approach the problem. Cosine, this is just general information, you know. Oops. Here's how to approach the problem, said he. He went straight to the, you know, that Wikipedia article that has all the identities?
Yeah.
He went straight there. Oh. Watch the magic unfold. Said, check that identity.
Oh, that was that one identity that we just divided by.
Maybe, we'll see. Sine squared. Sine squared alpha equals 1/2, and so therefore alpha equals 45 degrees. Does that make sense?
Whoa. Yes, but I have no idea how that happened.
It's like magic.
I know.
So what we want to know is all the 45 degrees in all the quadrants. You know what I mean? Does that make sense? All inverted. So if you took the unit circle and you're doing X, you want to know all those angles.
So just all the ones that cut it in half, all the 45 degrees.
Yep. So, and then you want the X values that intersect, go both ways.
So, are you ready?
Yeah.
It's negative. It's square root 2 over 2 and negative square root 2 over 2. They're all the same.
Oh, wait. I missed a step. That's what I thought it was too, but then you said, no, that's not true.
That would help to know if what you did was right.
So you said this equals that. But that's not the final answer. So, of course, you said 0 and pi. Those are the X values. And then pi fourths, which is, of course, 45 degrees. Three pi fourths, which is the opposite side. Pi fourths, which is in the third quadrant. And finally, 7 pi halves, which is in the last quadrant.
Whoa.
That drop the connect.
So, I guess I'll put that on the second line. So,
How did you get those numbers?
these are the radians. So this is what 45 degrees is.
Well, so it wouldn't be 7 pi halves, it'd be 7 pi over 4.
Oh yeah, it would be. Oops, my mistake. I put that wrong. So does that make sense, I guess?
What?
Are those the answers?
Mm-hmm.
I'll be right back, guys.
Quarters by Brennan law. Those are indeed the answers.
Can you just like walk me, baby step me, like hold my hand through these steps to get that? 'Cause
Sure.
I feel like this will be another question that comes up on the exam next week.
I'm sure it will be too. So cosine of alpha times the sine of 2 alpha equals sine of 2 alpha. That's one of the identities we know. And he told me it'd be a good idea if you just knew, especially this one right there. He
That's
said,
an identity.
Yeah, just know that. Just know that.
That cosine squared alpha equals 1/2.
Mm-hmm. And if they don't give you a variable, that's what you have to assume.
Okay.
Or they don't give you a number to, if they don't assign a number to the variable, that's what you got to assume.
That cosine 2 alpha equals 1/2.
And to get rid of that squared, you have to do this. You get that because, squaring both top and the bottom. Yeah, and then you get that.
Alrighty, sorry.
when you rationalize the denominator. And we know from the unit circle that root 2 over 2 is equal to 45 degrees. And then from there, you want to find, like I said, 0 and pi, of course, which are your 0 and 180 degrees.
Right.
And then you want to find every of those cutting in half angles on the unit circle, all 4 of them. Does that make sense?
Yeah, I said I have to go back and review my identities because I couldn't. That one identity was not one that I saw or easily picked out from the list of identities.
So that's what you want to remember and memorize.
Yeah, I mean, that's not on the list of identities, but I mean, hey, that's an identity that we can use, and I'll go with it.
Where are you pulling your list of identities from?
Dummies.com.
You pulled it from Wikipedia. Wikipedia. Okay, I've actually seen professors reference this particular article from Wikipedia. So the Wikipedia article about trigonometric identities has an extensive list of identities. So,
Holy crap!
did you just see it?
There's so many of them. I don't even know what to look at.
Mm-hmm. So that's what I'm. It's a very, very, very extensive list of trigonometric identities.
Whoever did this site did it well.
Well, they used to have to do that back in the day, before calculators. People would pay, like when you would get your textbooks, you get a chart with all those identities. That's what my math teacher was telling me. Anyway.
So you used to have to pay someone or you used to have this list in your textbook?
This used to be like a legit job. People would manually go and figure out those identities. And the people made good money for it.
Well, I mean, I'm sure.
But now, so you used to be able to use your calculus class skills back in the day, but not as much anymore.
No, there's no real point. What identity is this? Do you know?
I don't know what it's called. No.
I'll just have to go through and randomly search for it.
But I
Because
think
at some point they start using.
Sorry?
Go ahead. No, I was just saying at some point they start using random other words and letters and big letters, and it loses me after that.
For real, though. Okay. I think we've all had our fair share of pain today. Do you all agree?
Yes.
Yeah, I'm done. My internet's saying it's had enough too.
You can hear it. You can.
Oh, do you still got dial-up? Anybody remember that noise that dial-up used to make?
No.
Oh yeah, that sounded annoying. It's terrible. That's how I feel because I'm in Park City right now, and it is horrendous. Like everywhere I go, there's like no internet ever.
You know what's cool about Argentina, though? They got Wi-Fi in their parks. They got Wi-Fi in their parks.
That's true. That is true. Yeah.
I mean, why doesn't the U.S. do that? I mean, that'd be cool. Put Wi-Fi in the freaking park.
Is it good Wi-Fi, though? Like,
oh, yeah. I mean, it's good enough for people, like, not all over the city, obviously, but if you're in the park, it's pretty good. For its missionaries, we only had Nokia brick phones, so it wasn't much use to us. But the people I talked to, they said they got their homework done and everything in the park. Excuse me.
Dang.
Alrighty then.
Anyways, I'm going to go back to bed.
Okay. Sounds good.
All right. If I have any questions, I'll make sure to text you guys.
Yeah. Catch me outside. How about that?
All right. See you guys later.
See ya.